Okay, guys, so even though I'm not going to be in class on Wednesday, I wanted you to have the option to move forward. Have the option. That sounds so polite. I wanted you guys to keep moving forward. I'll just leave it that way. Okay, so we're going to talk about parabolas. Now, you've seen parabolas before, but not in the context of conics. So I'm starting with a very simple parabola, which is of the form y equals x squared. Hope you've seen it before. Hope it's probably the first parabola you ever saw. But parabolas in ancient times, they had a rule. If you've seen the last video I put up, which you should have, all the conics have a locus, a rule that describes what they do. And the parabola's locus was described in terms of its focus and directrix. I don't think you've seen those before in this context, so let's dive right in. Now, the general form of, rephrase that, the standard form of a parabola is one of two standard forms. It's either y minus k squared equals 4p x minus h. That letter p should be the only new thing there, right? You've seen y minus k and x minus h a fair amount. And then the other version is x minus h squared equals 4p y minus k. Now, which version you see immediately tells you something about the parabola. For example, over here on this y equals x squared. Hopefully you guys remember this is a smiling parabola centered at the origin, vertex at the origin, and it smiles its end behavior as it goes up to infinity in both directions. That's your standard parabola. Anytime the x term is squared in a parabola, it's either smiling or frowning. Over here, we have x minus h squared. If you want your parabola to be going up or down, or if you're given an equation for a parabola with where the x part is squared, it opens up or down. Which way? We'll get to that in a second. If you see the y part is squared, if you see the side where we have y minus k is squared, then this is a parabola that opens left or right, because we're going to talk about parabolas that open left or right now as well. Okay, we are looking at a parabola here that opens up and down. We already knew that, but if we didn't, this is the form we'd be trying to kind of hammer it into. Now, h and k represent the x and y coordinates of the vertex of any parabola you're looking at. So h comma k is the vertex. This letter p, that's a little different. It's letter p that shows up in each one. Okay? That constant, that number in each parabola, tells you how far the focus and the directrix both are from the vertex of the parabola. P tells you how far to go to find the focus and the directrix. What's the role of the focus and the directrix? Well, that was in the last video you were supposed to watch, explaining how conics were thought of and were used in ancient times. Okay? Now, let's keep going here. Okay. In this particular case, we're looking at the x is the squared part. I don't see a number in parentheses next to the x, so I'm going to assume it's a 0. I don't see a number in parentheses with the y, so that's also a 0. Okay, this part gets a little bit fun. This is where we put 4 times some number, and that's going to be our p-value. We don't have a number, okay? It would normally be the coefficient in front of the y value, but that's a 1. It's 1y equals 1x squared. Okay, but we have to put 4 times something. The 4 is vitally important. There's some crazy, great geometric explanations for why that is that I wish I had more time to discuss. But since all we see are, we don't even see them, all we understand to be here are 1s as coefficient, this must be 4 times 1/4. There must be a p-value of 1/4. And that's the reason why we don't see a coefficient leaping out at us. That 1/4 must have canceled out the 4. That is always baked in to this way of expressing a parabola. Okay, so we know the vertex is at the origin. We're going to put that there. Okay, now this graph is going to be terrible. Not even going to lie. Okay, so p is 1/4. All right, if the x is squared, because x is squared, this thing opens up or down. Because p is positive, it opens up. Okay? So here's what we do. I'm suddenly wishing I had started one where the value of p was 1/4 and where this graph is terrible. I could change the scale, but I'm just going to live with my poor planning here, and we're going to roll through this. Okay. This thing opens up. The focus is always inside the parabola. So knowing that it opens up tells me the focus is going to be directly above the vertex. How far above the vertex? Exactly 1/4. I realize that is not remotely 1/4 to scale, but please roll with this. Okay, so that's where the focus is. The coordinates of the focus then must be 0, because it's above the origin. It's not going left or right. And then the y value is 1/4, because we have a p value of 1/4, and it has to be directly above the vertex on the y-axis. Okay? Now, there's a line called the directrix, and the directrix is always perpendicular to the axis of symmetry of the parabola, which is a fancy way of saying it is perpendicular to, either up or down. So at 1/4 of a unit below the x-axis, we have the directrix. I'm going to try and take advantage of Notability's straight line drawing ability to really snuggle that up there. But that would be the line y equals negative 1/4. Okay? Y equals negative 1/4. All right, now if you saw the last video, the definition of a parabola was it's the set of all points that are equally distant from a focus and a directrix. Equally distant from a focus and a directrix. Well, it turns out if you go, let's see, a certain distance away from the focus to the left or the right, there is a point where you will be that same distance from both the focus and the directrix. Again, my drawing's not to scale, but that distance is twice your value of p. Okay? P equals 1/4. Therefore, you draw points 2p units away from the focus to give your directrix your shape. And I believe that you just saw my iPad screen disappear for a moment on your recording, and hopefully it is now back again. So you draw points 2p units away from the focus. In this case, that's left to right, because if I go, and again, I apologize for the poor scale here, but if I go 1/4 of a unit up to the focus and 1/4 of a unit down to the directrix, that means the total distance between them is 1/2 of a unit. And then if I go 1/2 of a unit to the right of the focus, that means this pink point I just drew is exactly 1/2 a unit from the focus, and it's 1/2 a unit from the directrix. That means it must be a point on my parabola. If I then go to the other side for symmetry, and I go 1/2 a unit to the left, and then 1/2 a unit down, I will have another point that is exactly 1/2 a unit from the focus and 1/2 a unit from the directrix. That must also be a point on my parabola, and that is the way you draw a parabola, by constructing this box. It's kind of, the vertex is in the middle of it. It is centered on the vertex. It is p units up and down from the vertex. It is twice p units left and right from the vertex. I thought it'd be simple to start with a familiar parabola that you already knew, y equals x squared, but honestly, that tiny scale in this graph did not make that easy, so I apologize for that. Let's go ahead and do this next one and see if that is a little easier. Okay. In this case, I don't see any other ones I really want to go to here that are, okay, we'll get to that. All right. We have another one centered at the origin. So I'm going to rewrite this. In general, we like to keep the side that's squared on the left. You don't have to, but it's what most people are used to seeing. It's basically kind of a tradition at this point. So since the y is what's squared, I am going to write y minus 0 squared. There's no number there. If there was, we'd see it in the parentheses. Equals negative 4 x minus 0. Oh, I'm actually not going to write it that way. Thought I would. I'm going to write this as positive 4 times some number times x minus 0, because remember, the general form of this has to be y minus k squared equals 4p x minus h. H and k are the center. Since the center is 0, I'm plugging in, since the vertex, I'm sorry, h and k are the coordinates of the vertex. Since the vertex is at the origin in this case, I'm putting in 0 and 0. I have this negative 4 that was conveniently in front of the x. I have to change that into 4 times some other number to find my p-value. It looks like p is going to have to be negative 1. Okay? So I'm going to go ahead and draw my vertex at the origin. Now, the y is squared. This opens either left or right. Since p is negative, is less than 0, this opens to the left. Okay? Another way to look at that is the foci, the one focus point, the focus, the only focus of this parabola, it's singular, not plural. Since p is negative, from the vertex, you draw the focus to the left. If p is positive, you draw the focus either right or up, depending on which way the parabola opens. If p is negative, you draw the focus either left or down. P is negative 1, so I drew the focus 1 unit to the left of the vertex of my parabola. The parabola will open around this focal point, and that's how I know it'll go to the left. The directrix has to be the same distance from the vertex as the focus, so it must be the line with the equation x equals positive 1. And the parabola opens this way. It opens to the left. Okay, I want 2 more points to give this parabola its shape. P is negative 1. If we double that, we get negative 2. So here's what I'm going to do. I'm going to go to my focal point, okay? And I'm going to go parallel to the directrix, perpendicular to the axis of symmetry, if you remember that term about parabolas. But I'm going to go parallel to the directrix 2 units up and down from this focus. I always go parallel to the directrix. My distance is always twice P. So I'm going to put a point 2 units up from P, 2 units down from P. It should be a little bit easier to see now that these 2 pink points that I just filled in, they're the same distance from the focus as they are from the directrix. That is literally the original old school definition of what a parabola is. It's a set of points that are all the same distance from the focus as they are from the directrix. The vertex meets that condition. It is 1 unit from our focus. It is 1 unit from our directrix. These 2 pink points meet that definition. They are 2 units from the focus. They are also 2 units from the directrix. That will always happen if you go twice the number of units as you've discovered for your value of P, parallel to the directrix, away from the focus. Connect these 3 points. That is my parabola. I don't know if I mentioned it in this video or not, but we just designed a 2-dimensional cross-section of a car headlight. Car headlights always place the bulb at the focus so that all the light that bounces backwards from the bulb will hit the reflective surface on the inside of the headlight and will fly out of the parabola perfectly parallel to the axis of symmetry, perfectly perpendicular to the directrix. Archimedes understood this principle and tried to build a laser over 2,000 years ago. These guys were smart. They knew some things. Okay, that is how I would graph that parabola. The only difference between problems 3 and 4, which I'll leave for homework, are you would start this process at different points. You would start this one with the vertex at -3, -4. You would start this parabola with your vertex at the point +2, +4. Both x's and y's are counterintuitively shift. Make sure you put the x coordinate based on the number you see next to the x value. Make sure you put the y coordinate based on the number you see next to the y value. Which one's on the left or right does not matter for that. I'd also like to apologize in advance. It appears your p-value here is -1/4. That's not going to be as much fun as we'd like. But I want to make sure I get to at least one of these. One where you're given this general form and you have to rearrange things and complete the square in order to figure out what you're looking at. Okay, I don't see one of these as being particularly better than the other, but let's see where it goes. All right, let's try the first one. So, I like to have the x squared or y squared on the left. So it looks like on number 5 here, the x squared is already on the left. Not sure that I like that negative. I may get rid of that later. But I'm going to leave the x squared and the 4x there. I'm going to subtract 4y from both sides, and I'm going to add 20 to both sides. Okay, good first start for getting it to look more the way I want it to. I don't like negative leading coefficients. Go ahead and give a spoiler. We're about to complete the square. I like to do that with a positive 1x squared. So I am going to multiply everything in this equation by -1. then it becomes positive x squared minus 4x equals positive 4y minus 20. Okay, I am now going to take this negative 4, divide it by 2, square it, and place that value right here. I'm going to add 4 because I'm about to complete the square. If I add 4 to this side, I also have to add 4 to the other side. Now, that's going to give me x squared minus 4x plus 4 equals 4y minus 16. The only reason to do that is so I can rewrite the perfect square trinomial on the left as x minus 2 squared. And I'm going to go ahead and factor a 4 out of both terms on the right, and that leaves me with y minus 4. Oh, I'm so close. I'm just going to do one more step here. X minus 2 squared. Cool. That looks like x minus h squared. Oh, I need this 4 to be 4 times p. All right. 4 is a nice number for parabolas because that means p must be positive 1. Y minus 4 can stay right there. P equals 1, which is greater than 0. It's positive. The x is squared, so it opens either up or down. P is positive, so it opens up. Where does it open up from? Well, its vertex is at positive 2, positive 4. That's a point I would put right there. P is positive 1, so the focus is exactly 1 unit above the vertex, and the directrix is perpendicular to the direction of the parabola, exactly 1 unit below. That makes it the line y equals 3. Okay, I like 3 points for my parabola, so now I'm going to construct the other 2 points. They will be, all right, P was 1, so I'm going to double that number, and I'm going to start at the focus and go parallel to the directrix 2 units in one direction and 2 units in the other. So if I place these points, one of them at 4, 5, it looks like, the other one at 0, 5, that'll give me a good start for what my parabola looks like. With my vertex at 2, 4, my directrix at y equals 3, and my focus at 2, 5. I'll go over a few more of the terms in class on Friday, but this should be enough to get you started. Mr. Tyson can answer any questions, and I look forward to seeing you guys on Friday, and I'm sorry I couldn't be there today. All right, take care.